Hello, people. Lux, congrats on the first. Hope you're doing well. Okay, I think the music's at a good volume. Okay. Not today, Slim. Honestly, I want to, but it's been too long since I've done math, so today will be a math day. Okay, so I think once we get a question from chat, there's two kind of outstanding things in my Discord that I want to figure out. So Thunder posted this question about volumes of revolution. And the question starts with basically, why should shells and disks give the same result? Hey, Fembucks. And I tried to explain that, but Hunter gave this specific example, and when I tried to do this example, I got two different results, and I'm not quite sure why. So that's something that I'm hoping to figure out. So the work is a little bit messy. I still don't completely understand this drawing down here. I was looking at it for a while, but the problem is basically rotate y equals 2x plus 3 about the x-axis from x. Well, I guess we can give the xy pairs. Hey, lacking remorse. Thank you. Your name feels familiar, and you're not a first-time chat. I can't remember what your name used to be. I have a feeling that's maybe I know you, and this is a name change. Enochian. That okay? That was gonna be my guess. I think because your color is still the same. Good to have you here. I'm like, oh, that is man versus game. Oh my god. I used to watch his stream. He was an OG of Twitch. Justin TV even. Okay, so something like that, and we're rotating this portion down here. So I don't know if the shape even has a name. This is I'm not gonna draw this. It's like a cylinder but with slanted sides, or a cone if you chop it off. Ooh. Okay. Like the bottom part of a cone, not the top. I might have figured out where the mistake is. I think it might be this y. It should be y minus 1, maybe. Yeah, Jed, we could even see if that result matches. It definitely should. Okay, I don't want to do this integration by hand. I'm too lazy. But I've got a friend who's just a whiz at integrating things. So we'll start with doing disks, which is in terms of x. So from 1 to 2, 2x plus 3 squared dx. 109 pi over 3, that matches what I got off stream yesterday. And then cylindrical shells. So this is in terms of y now. It goes from 5 to 7. Oh, that's not 7. That's 7. And I'm saying this should be y minus 1. Thunder has y there. What's the other thing? It's the equation for the line rearrange. Y minus 3 divided by 2. What? That's not. 23. Nobody loves you when you're 23. There's it likes you? Oh, that's not good. There's 2 pi. 90. So y, I'm gonna solve this by guessing. Is it y plus 1? Nope. Okay, we need to think a little bit harder. Unfortunately. Just why it gives you 110 pi. That's the issue that I ran into last night. So 110 versus 109. It's like just barely off. So how do shells work? For shells, I'm drawing a circle. Call it a rounding error. Perfect. A circle, or we're making the small cylinder we make is a cylinder like that. And the biggest cylinder we make is like that. This is not a very helpful drawing, I don't think. But it's definitely like, I think this bit right here must be the issue. Wait, am I understanding cylinders correctly? I think I'm not. Or shells. We're integrating in y. I'm having trouble visualizing how the shells are supposed to look now. This is rotating about the y-axis, but because integral will be in terms of x. So x is the radius of the cylinder. The function is the height of the cylinder. And dx is the thickness. Hey, Yug, why did I decide to start streaming? That's a good question. I don't know, I just thought it was a good idea for a stream, I guess. Just to do a math help stream. I just felt like it was something that could be successful. And when I started doing it, I just found that I really enjoy the community of people who turn up to these streams, so yeah. I'm missing something here. No, I think maybe I'm not. Organic chem? Ooh, good luck with that. Oh yeah, I okay, I don't know why I was drawing a cylinder like that. That's not. It's still a cylinder like that or something. Um okay, so no, the radius is just y. Maybe I guess I was wrong about that before. What the hell? I feel like Thunder. Okay, I'm back to saying that Thunder just did it right, and we're getting the two different results now. um, hey Aditya, what college did I go to? Not one that you've heard of. It was a small college, not much of a math one. Hey Rex, you're vigorous in words and action. Ooh. Also, I'm just noticing, was this also made in Journal Plus Plus? That shade of red and green, or the red. I don't know my colors. Green and blue feel like the same as mine. Uh, that's your music? Oh, nice. I don't think I'm trying this. What the fuck is this cylinder supposed to look like? I'm clearly very rusty on my cylindrical shells. Yeah, it's a question that was posted in my Discord. They're asking about why disks and shells should give the same result, and they provided an example problem, and I can't get the same result with both methods, and it's really annoying. Um, hmm. That's why is that tick mark there? Kind of weird. It's just show an arbitrary y. Yes, Daddy GPT. I'm okay. I want to figure it out for myself. Radius times height. Let's find out. Well, this is a little prescriptive, but it's fair enough. Hey, Techa. Yeah, right. Long time no see. Hope you've been good. I'm doing well. Thank you for asking. Surface area of a cylinder, 2 pi RH. This should just work. Nah, I I'm gonna do math, but I hope that you enjoy the chess. Yeah, Dojo, I think I'm doing something like that right now. I'm getting kind of annoyed at myself that I can't do this. Okay, should we do it the geometric way with cones to figure out what the right answer should be? Because what if we are doing shells right and we did disks wrong somehow? I doubt that's the case, but let's find out. So this is a cone of radius 7. Um, we don't know the height of it, but we need to use trig to work it out. Hey, collar cone. Speaking of cones. That's a 7. Teja, I'm trying to do a solid of revolution problem. I mean, this is it's written right there. What I'm trying to do. I'm trying to do it with both disks and shells, and I'm getting 2 different answers, and I'm trying to work out why. Okay. Oh wait, maybe I'm doing this. If I want to work out this angle, this side down here is 1. What's this vertical? It's gonna be the slope. 2. For every 1 change in x, we get a 2 change in y. Okay. So then if I want this angle up here, I want arctan of a half. Cones, they use cones to take limits in category theory. Oh, I did not know that. I didn't know you could take limits in category theory. At a miniature show with my wife, someone is turning super small plates and vases on a wood lathe. Wow. Enjoy the show. That's cool. Well, I don't know why me unless maybe there's a joke in there, but no, Femvox, I don't know. I'm trying to work this out with geometry to figure out what the right answer is supposed to be. I can't figure out for the life of me where the mistake is though. Oh, rotating. I get. Okay. Yeah. Nice. Um. It's even a limit. I couldn't tell you what that is either. Category theorists like double their number of words by adding the word coconut. Oh yeah, I mean, so yeah, that's actually a great idea. We should add a second level of if you want to triple your number of words, or would that be squaring? Tripling? Squaring. Or would it be 2 to the power of that? I don't know. It's something. I'm getting distracted. The point is, this angle is theta. So then, 7. Oh my god, tangent is opposite over adjacent. So if I do tangent of arctan of a half, isn't it just 7 over 2? Oh, they need to be in ratio. Duh. Okay. Yep. That makes perfect sense. I didn't have to do trig at all. I could have just known facts about lines to work that out. Okay. The volume of a cone, I think it's a third pi r q or pi r squared h. Okay. Radius 7, height 7 over 2. Oh, and we need to subtract a cone. We need to subtract the portion. But we need to subtract the portion we're not rotating. So take 7 over 2 minus 1, which is 5 over 2. Which means that height there is 5. Okay. A third pi times 5 squared times 5 over 2. Okay. So discs is correct. Shells is wrong. As we thought. That took way too much effort. Example of a limit is a kernel of a linear map. Example of colimit. Okay, I know what a kernel of a linear map is, I guess. I don't know why that would be a limit, but fair enough. Colimit would be the co-kernel. I don't know what co-kernels are. The only co-kernel I recognize is co-kernel Sanders. Cocones? Crokinole? I don't. That sounds like a creature. Hey, Obi. Alex, you also get 109 pi over 3. Yeah, it's kind of a shame that Shells is the harder one because, like, it is really helpful so sometimes. Hey, Central. Shit. Um, just cycling through them all. ZFC, think of KFC? Yeah, it's like Zimbabwe fried chicken. Or is there... That's the only country I can think of that starts with Z. I feel like there should be another one though. How many of these do I have? Yeah, you have to be getting to the end of them soon. I got a few more. Oh, Pome Fritz. Thank you for the follow. Is that French for fries? It almost looks like it. Actually, I mean, it's probably a little bit off. You know kernels that measure the injective of your map. F is injective if and only if kernel of F is equal to 0. Ugh. Okay, that sort of makes sense. Co-kernel measures the surge activity of F. Okay. That makes more sense. Co-kernel close enough for me. Was that annoying? Yes. Gamma, that doesn't work on this scene. Peri fried chicken. I have heard of that. Milk was a bad idea. I don't know where that's from. I've heard people say that though. With Shelter, you have to split the integration into parts. You do. A hockey puck in the middle with a sloping... Really? Trip Donahue, thanks for the follow. Hey, Piggy Master. Um, I did see what you posted, and I was planning to work this out first and then take a look at what you posted. Um, bald? Nearly bald, yeah. I gave myself a buzz cut. Yeah, I know that kernel null space are the same thing. Um, thank you, thank you. What about pre-image? Pre-image is in there somewhere, I think. Eldritch, I just decided to chop it off. I tried to cut my own hair. It didn't work out that well. And I didn't want it to grow in unevenly, so I just buzzed it. So that way it's definitely even, at least. um oh no, my hair is getting way too long, and haircuts here have gotten stupidly expensive, so just didn't want to pay a barber, I guess. um I was saying that I think that makes sense. That's why I was probably struggling to draw the shells. So we just have a regular cylinder in this portion down here that we can work out the volume of. And then just in this portion, pay barber from Morocco to do a shave and haircut, like 20 to 30 pounds once. Wow. That sounds nice. I never gotten a shave from a barber before. I've only ever done it myself, but it sounds really nice. Like if I had spared money, I would like go somewhere and get a proper like beard trim. Scary. Oh yeah, because of the blades they have. I think those things are cool. Like just like I think they're called straight razors. It definitely is like when you say it like that, you do have a point. Yeah, that they are basically holding a knife to your throat. Okay, I really should be able to draw what these shells look like. I guess the small shell would look like that. Okay, I think this actually works. Yeah, Obi, I feel like I'd have to be constantly apologizing for my country if I was visiting somewhere else. Especially Canada. I'm not even that far from Canada, so it'd be really cool to like visit it, but like yeah. Wouldn't sneeze while he's working on you. That yeah, $10. Oh yeah, Dojo, I've seen that. Okay, so how do we fix this integral? Um, wait, this doesn't make sense. Um, Tejo, what's the question? Shouldn't this have been an underestimate, not an overestimate? So I want to just do plus and then the volume of the inside cylinder, but that's not. I'm gonna get an even more wrong answer. So the integral needs to change. But how? I think it needs to be translated or something, doesn't it? Well, does it? Is shells actually getting me like? Oh, maybe it's giving the other. It's giving like. It's forming shells out here. Could that be the issue? Man, I hate this method. I'm fucking this up. I feel like I used to be way better at this. Point of colimits to abstract out rather complicated computations. What is kernel of a linear map? Obtained as a product of other maps. Kernel essence tell you limit commute with limits, so it's a product of the kernel. Okay. Yeah, Femvox, the hockey puck is the easy part, I think. It's that I'm gonna get the wrong answer when if I were to do the integral that I thought is right for, okay, let me. I thought this integral would be this part up here, and then we can do plus 2 pi r squared h. So the radius is 1. Wait, no, I lied. The radius is 5. And as you say, the height is 1. The issue is this is already an overestimate of the correct answer. So if I add something to it, I'm going to be even more wrong. And that's what I'm trying to work out. So this integral is still wrong somehow. The height is 2 minus. I guess this would be the height here. And so what you're doing is you're basically, I think you'd be putting the line up against the y-axis. If you do that, we can try that, see if we get the right answer. That's negative. I don't know. Wait, I did plus, or I did minus. Okay, it's still not right, but I don't know. Teja, that might just be a telescoping series, and I'm able to do that one quickly, because this problem's taking me longer than I thought it would. Um, I think this should be telescoping. To check, let's write out the first few terms of this. So when n equals 0, we get 1 over 1 minus 1 over 2. When n equals 1, we get 1 over 4 minus 1 over 5. When n equals 2, we get 1 over 7 minus 1 over 8. I think there's a way you can figure out how long it takes for it to repeat based off that coefficient there. I don't know. I don't remember how it works though. So we did 0, 1, 2, 3, 10 minus 11. Does this not telescope? Am I doing this wrong? Okay, I don't know then. I can't do this one quickly. Do you already know the answer to this question? Okay, yeah, if you actually like needed help with it, I would prioritize this more, but the thing I'm working on right now is like someone asked me to a question about the Salt of Revolution thing up here, and I'm gonna prioritize trying to answer that for them. Integrals, I hate the Riemann sum thing. I don't want to do it. Co-kernel type of computation you probably know is finding solution to Poisson equation delta f equals g. Solution of g is the co-kernel of delta. Huh. That makes sense. Oh, yeah, Teja, I'm definitely not doing that question then. um, oh God. Uh, yeah, Pomace, I'd rather just not go there. I'm gonna delete that message. No hard feelings. I probably said too much myself to invite people getting political. I'd rather just not go there. No, it's my fault for making a comment like that. So I try not to blame people if they're just like responding. And you were respectful in how you like said it too. So um Okay, yes. So I think the issue with this integral is that I'm forming the wrong disks. I don't know how to make the right ones though, or the right shells. The shells I want to form are like below the line. But the shells I'm actually forming are above the line. Um, how do I fix that? If I did, so this maximum height here is 7. If I did 7 minus this line, would that fix it? Nope, made it worse. It should be something like that though. Or maybe it's this line minus 5. Weirder. Wait. God damn it. There's another mistake somewhere. 50 pi is already more than 109 pi over 3. Oh my god. I hate this. I hate this. I want to just forget about this question. Ah. Where is the mistake? Oh, wait. Okay. I get it. I think. Wait, do I get it? Uh, I think I lost it. Never mind. No, yeah, I lost it. This is so confusing. I think I think this top integral isn't the sort of revolution that I think it is. Because this cone just from, or the cylinder just from this square portion, or rectangular portion, that's 50 pi. But the answer that this integral gets is less than 50 pi. How is that possible? We make it 15 pies? I wish I had 15 pies. Is it really? Can you post or share like how you got it? Because this is driving me crazy. Okay. Volume of a cylinder. Pi r squared h. The height is 1. The radius is 5. Yeah, I'm fucking confused. I have no clue. Apparently I'm very rusty on solids of revolution. Wait. No, but I know 109 pi over 3 is the right answer. Because I did it the geometric way. Am I calculating the volume of the cylinder wrong? Like, how else is this possible? Yeah, sure. I have a few pages of Wolfram open. This is the one for discs. Sorry, Dojo. I appreciate you, or I appreciate your spirit. The one with the two-part? This is... Oh, well, I was messing with this one. I did 2 minus the thing that you originally said. Yeah, I know we always have the opposite. We're rotating around the x-axis. And for disks, I think that means we do dx. That'd be a very basic mistake to make. No, I'm pretty sure I'm doing it right. This says shells do it in dy. So I think it's only 25 pi? Oh, I just added in a 2 for fun. Oh my god, that's what I was doing wrong. Oh my god. What a stupid mistake. Okay, so then why is it 2 minus? Thank you, $10. That was driving me crazy. Okay, it's 2 minus... Because the height of the cylinder is x, or that I okay, yeah, because the height of the cylinder is measured from 2 out to x. Oh my god. Okay. Thank you, Fembox. You rescued me. Um Restriction. Yeah. Well, I hope my relief is equally palpable now. Saved by Fembox, not for the first time. Okay. I want to write something up that hopefully Thunder will understand. That's not discs. Yeah, like I have too. I haven't gotten beaten up recently enough, I think. Oh, you probably gotten even then you've gotten beaten up by them even more than I have. Okay. Okay, hopefully that uh will make sense to Thunder. We'll type up a little thing to go with this too. And we do have some Papadhoria questions to think about after this too. Uh, I, oh wait! Scrap this! Scrap this! Scrap this! Scrap this! There's a second component to Thunder's diagram that I haven't even thought about. This entire thing is me being stuck on this part of Thunder's diagram. I haven't even thought about what Thunder was doing in the second part down here. It's a little bit hard to read. Let me go to the Discord version. The rule of it was when you're stuck, draw a large diagram, quickly label all the links needed. I was having trouble identifying the links needed. Like I couldn't like visualize how the shells are supposed to look. I don't know what Thunder's doing here. Why? B1. Oh, hey, yeah. if you take the result from disks and the incorrect result we originally had from shells and add them together, you should just get a cylinder, I think. Yeah. And that might be what Thunder is doing here. Oh, wait. Okay, maybe I... Hmm. Okay, you know, I'm not sure I understand what Thunder is trying to do with this. Let's at least give this update that we have so far. I think Thunder is trying to make this original integral work. Hey, Martin. And so Thunder is noticing that, well, I think Y1 and Y2, I guess it's 5 and 7. And so I guess, ooh, maybe this isn't even going to help Thunder if I type out what as well just type out. So I guess it looks evident that Thunder knows if we did this integral. Wait, you can't see my cursor, can you? Now you can. If we do this integral here, it's gonna, our cylindrical strips are going to go like from this line to the y-axis. And Thunder, I guess it's subtracting out this square here that we don't want. But I think y1 is 5, y2 is 7. Based off of this notation here. Also cramming for incoming exams on the 1st of April. Ooh, good luck. What class is it for? Or classes? Okay, so in 10th grade. Okay, yeah, this is like a calculus thing. If you have a question, feel free to let me know. Why are we doing y2 minus 3 and y1 minus 3? Okay, let... to get the same answer with shells with what's in the attachment, where I'm still not clear is in your work, you're using shells in a different way. Yeah, I missed the Thunder. Haven't actually. I think Thunder said hi somewhat recently, but they don't come around as much as they used to, which is okay. But it's always good to hear from Thunder. Um, are you trying to add up the results from disks and your V2 integral from shells to make a cylinder? Thank you, Color Cone. Confusing to me. Okay, maybe let's leave it at this. Oops. All right, that was a doozy. We're still not done with it, but I think we need to wait to hear back from Thunder. I don't know if Papadhoria is still here. Maybe I'll... He was here in Twitch chat before, so I'll type his name. But we do have some patented Papadhoria questions that we can think about too, that he just posted a few hours ago. Intuition? Yeah, certainly. Two methods should give two different volumes, they're referencing two different areas in the graph. Yeah, so it's a really good question. Like I couldn't really figure it out on my own. Okay, so I did read through these when he posted these. One seems kind of interesting, but tricky to actually do calculations about. Um, Two, I think I just know the answer to this. I need to remember what the name of the function is, though. But there's like a Dirichlet type of function that fits that bill. I think Thunder just replied. Trying to see what the shell method was giving me. I'm still not sure what area it's rotating about the x-axis. Well, okay. When we use shells, we have to incorporate the 2 minus height idea to shift the blue region to be inside our volume. I hope I'm responding to Thunder properly. I'm worried I'm still misunderstanding. Instead of region has a height of x minus 0 instead of 2 minus x. Right. Uh, the important difference is the height of the cylinder. You use y minus 3 over 2, and I use 2 minus y minus 3 over 2. It's definitely useful. I just get kind of frustrated. Um. Oh, okay. Thunder. Perfect. This will be easier to explain. Oh, ads. Okay. Hey, Thunder. Thank you for popping in. This will be easier to explain verbally, I think. um. So yeah, with a lot of help from Fembox, we were able to work out how to get the same answer with shells. So, um, where to start with this? Let me make some room. But yeah, like we were just saying, you have really good intuition for this stuff. And you've asked a really good question here that has been tripping me up for sure. um, So yeah, so for this integral you set up for v2 here, I feel like I need to make this picture even bigger. Let's just get rid of this. Hope you're enjoying calc. Yeah, shells is it's confusing. It can be really powerful, but it's confusing. Okay, so the thing that you did like really amazingly here is that you correctly identified that this integral gives you cylindrical shells in this shape, where like your smallest shell has a, let me get a different color, maybe red. Actually, not red, because you already used red. Dark blue. Your smallest shell, oh god. Is going to look like, dude, I can't draw for crap, but something like that. It'll have thickness dy. Height is x, but x equals y minus 3 over 2. And the radius is y. Yeah, exactly. That's part of what makes this so weird. um and so you have a really interesting like idea here seemingly, which is to realize that you're going to get this part that you don't want and subtract it out. So we can definitely, like, this part here kind of forms like a ring that we can definitely figure out its volume. And then once you do subtract that out, you realize that, well, these two solids together will just form a cylinder, it looks like. And we know how to deal with cylinders. The thing that I would like, this is like kind of convoluted. So the thing that I posted is how to do it a little more directly, but I didn't necessarily explain it fully. But I think your idea here should work if you're trying to like verify you're getting like consistent results. I think this integral down here for v3 is a little bit, I'm not sure that that's quite correct, but I wasn't sure. I was still trying to figure out what you're doing with that, but it might not be important ultimately. Nothing much, just basic trig stuff. Okay, fair enough, Martin. Still, good luck. Trig can be tricky sometimes. Chop off the bottom of that blue volume, end up with a little section outside of the green volume we want. Right. The main point is like, does the shell method in this case rotate the area between the curve and the y-axis? And the disk method rotate the area between the curve and the x-axis? Well, so here's the thing. If you're just doing the shell method formulaically, yeah, Obi, Martin in the YouTube chat is apparently about to take a trig exam soon. So if you're just using the shell method formulaically and plugging and chugging, you do get a different result. The thing I was trying to say is that you can make the shell method work by doing a 2 minus. like inserting this very important to, yeah, because it completely changes the nature of the thing that you're integrating. So this is where you have to be like kind of like quote unquote smart. Inside green hockey puck that's too small, so an outside hockey puck that's too big. Right. So how should I say this? Okay, so let's maybe back up. So the formula for shells is 2 pi, shells about the x-axis, y1 to y2, radius times height, oops, dy. So the thing that we want to rotate this region inside here. And for now, if we just focus on like this portion up here, we'll deal with the bottom part later, but just focusing on this part here. The thing we want in order to match the thing we did with disks, the kind of I'm searching for the right word here. Like I want to say strip, but I don't know if that's quite right. We're trying to capture this region here. I think that maybe the easier part to see is that the radius is just going to be y, because that's just the same logic as was in the integral that you set up. So let's fill this in as we go. 5 to 7 y. But if we want the height of the cylinder to be from here to here, well, this point right here is x equals 2, and this point right here is just x. So and we want this to be a positive, and like we're going to do right minus left, so the height is going to be 2 minus x. But then from the work we did before, we know that x is y minus 3 over 2. And so that's how we can kind of fix the shell method to give us the area just below this line, rather than on the left side of that line. Create the differential slice first every time. Yeah, that's what I was like trying to search for, but I am a little bit rusty. And so actually, that's I should probably maybe, oops. No, Felix, that's don't be quiet, be loud. Yeah, like the slice argument is a good way to think about this. I just need to remember like how exactly to phrase it. Doesn't this still rotate the area above the curve? No, because of how shells works. The radius is still y, And the height is just like 2 minus our function instead of our function itself. That's how we're ensuring that the cylinders... That's too dark to see. So like this very first cylinder originally looked like this with your integral, but when we do the 2 minus, it's going to be... Start from here and then go back here. It just gets rid of the red part. That's a little... I don't know what that means. R squared minus R squared. Where does it end? Well, the red part on your diagram. Well, so in your diagram, you basically used x minus 0. Whereas in mine, I did 2 minus x. So you have a built-in like 0 as your barrier there. I feel like I'm maybe not answering your question that well, but it's kind of the cylinder has a few different things working together at the same time that make this work. So like the bounds being from 5 to 7 is important. Yeah, no worries, Thunder. I'm doing a very good job at explaining this. So let me try to figure out the slice argument. I should really make this bigger. Yeah, so this thing has thickness dy. It has width 2 minus x. I guess the radius is just y. So the slice are the individual shells. I'm just like, it's basically this light green thing here, but I just like cut it so it's two-dimensional, like flat with our image. So I just took like one slice of the shell, I guess. And so I guess like you start with this and then you rotate it around afterward. Hey, Orange Hue. Good afternoon. And you can do the same type of slice thing with discs as well. Orange Hue, right now we're talking about volumes of revolution, which is like a Calc 2 thing. But I don't know the difference between two different methods for it. It's a really tricky thing that I'm struggling to explain well, and Thunder's asked a really good question about it here that we're trying to like work through. Andrew Dad, to integrate shells, first consider small rings with radius r, thickness dr. I haven't heard of doing it that way, Andrew Dad. Uh, no, we've only ever been integrating around x. Oh wait, so maybe there's something in your drawing up here. Just to be clear, you did mark out this area correctly, but like, are you saying you thought that the cylinders go like this? Because that's not right. The cylinders are going like around the x-axis. Well, okay, no, you said that before. I don't think that's your question. Okay, okay, good, good, good. Um, hey, Clonk. You get along very well with everyone except animals and people? Okay. Clonk finally got a bad one. That is funny, but it's definitely not true for Clonk. Views how what you're doing. You definitely no. You get along well with animals and people, Clonk. The method without any problem, right? I'm noticing. I'm more like I'm confused how what you're doing the blue area became the green area. Um, right. The height is the only thing we need to change. Like, Andrew Dad, it's currently 2:30 in the afternoon for me. So like I cut it. It was getting too long and I wanted to learn how to cut my own hair and it didn't go well, so I just gave myself a buzz cut. Yep, it's all gone. um Hope you're doing well, Who. It's always great to hear from you. Yeah, it feels all like fuzzy now, so that's fun. Like, thank you. But yeah, so Thunder, the only issue with your work was the height of the shells. Everything else was perfect. Means I can't lose to stress, exactly. Because your radius was correct, your bounds were correct. It's just we were using this for the height of our strips in your work. Or like, yeah, like I'm still not doing a good job of explaining this, but if we're doing the kind of strip thing, you're using strips like this. I'm using strips like this. The only difference between them is that height, aka the width of these strips. 3:02 a.m. Oh, geez, Andrew, Dad, you probably go to sleep. Okay, maybe that made sense. I okay. Yes. Okay. Good. I'm okay. Thank God we got the hard part done. I think. Um. Okay. So how this is just a a rectangle that we want to work out its dimensions. The thickness of this is always going to be dy when we're rotating around the x-axis. Right, Obi, I saw you say that. I hope I didn't misspeak before. I'm sorry if I did. But yeah, it is always true that like disks and shells are gonna have the opposite like variable for the same axis. So yeah, we're trying. It's just working. We're trying to work out the dimensions. The height is dy. The width, is like that length there, and so on the right side, the most it can ever be is 2. On the left side, that's going to be like the variable length x. So the entire length is 2 minus x. And then you remember that x is y minus 3 over 2. And Andrew, that's what I'm trying to like struggle through. I think I'm just a little bit rusty on shells, so I haven't been explaining it very well. And then what's not included in the strip is like the radius of these shells, but that's just y. And the only reason this would ever change is if you're rotating around like x equals 1 instead, or x equals minus 1 or something. Right. And so there is if we agree on this part, there is another issue we need to deal with though. And the other issue is that the work we've done so far only covers this triangle between y equals 5 and y equals 7. So we do still have a separate problem down here for this rectangle, but the work for that is a lot simpler. Yeah, it's like in this part up here inside the triangle, our strips are it's variable 2 minus x, and then down here the strips are just a constant width of 2. So that's like the only difference, but like the bottom part you can just work out as like a normal cylinder because things are constant. Okay, the circumference of each shells so that we can create the volume of the shells. Right. My way of doing it is basically the same difficulty. Yeah, I think your way is getting a little bit convoluted, but it would be a valid way of verifying you get the same result from shell and disks. Oh, thank you, Femlux, right. 2 minus 1, which is 1. And so that's why in the work that I included in the screenshot, I had this portion and then separately plus this portion. The left side is like the upper triangle. The right side is the bottom rectangle, which Founce is calling the hockey puck because it looks like a hockey puck. Yeah, Obi, it'd definitely be helpful for me to like to remember how it works. I'm a lot closer to remembering it now after going through all this. But yeah, I was having a really time visualizing what shells we're making with this. In general, for the formula, 2 pi integral x f of x dx does rotate the area between the curve and the x-axis. Well, if you're doing it with x, you're doing the y-axis. Um, but right, well, I think what you're saying is right, which is 2 pi x f of x. The thing that maybe you got tricked on, which I also was getting tricked on, is that this f of x isn't necessarily the function that they give you. It you need to think about the geometry of the shells. Um, and so that's why like our orthogonal will appear as radius times height, because it's not always the exact thing that they give you. Oh, nice, Andrew Dad. Good luck with the JE. I know about it. I know it's very, very tough. Don't gamble. Yep. Gambling's bad for you. But yeah, Thunder, really good question. Sorry that I misunderstood you, and sorry that my explanations haven't been the best, but I think we got there in the end. You use the function they give you, isn't it the rotated area? Um, it's always going to be yeah, if you just like blindly use this function and don't modify anything, I'll draw something random. You're always going to be rotating. So this is about the y-axis if we're doing it with x, remember? So it's always going to be, maybe I should draw a different function. You know what? I'm going to do it with y because I'm going to get mixed up, I think, about the x-axis. No, I should just do it right. I don't know. You, uh, okay, so this will be rotating around the x-axis. So if you just blindly don't modify anything, and you have some generic function, you will always rotate from the y-axis out to the function around the x-axis. But and so yeah, and so the reason that it was wrong in this exact problem is that you were trying to rotate something out here to the right of the function. So that's when you need to modify it. Sounds good, Martin. Good luck with your studies. And Fembox, yes. So finals week was last week. This week was my spring break. So I'm almost into my next quarter now. Or like my final quarter, even. You did prove them wrong? I guess it depends what exact statement they made, but a coffee stream? I'd have to figure out what to do for a coffee stream. I've only ever done one coffee stream, and that was like a special thing. It'd be cool. I don't know what it'll be like yet though. Yeah, it's like the entire program is just like a 1 year's thing, a 1 year thing. So as long as I don't completely shit the bed next quarter, I'll be graduating. Okay. Um, proofs to your friends wrong on the course. You know that's nice too. Right? Yeah. You also did, or you did yours in like just like straight up math, right? Yeah. Thunder, thank you for the question. Obi and Fembox, th- th- thank you both for the help. My 1 year master's has been super stressful so far. I'm hoping my next quarter won't be as stressful as the last quarter was. Okay, so these are the questions that Papadhoria posted. Kind of real analysis flavored. Yeah, Thunder, they are scary. This is like, I'd say it's just one step beyond calculus, but these are also just like, these are challenge problems in particular. Um, and the person who posted this is famous for like having really tough questions around the stream. So I don't know. I'm always happy to talk about stuff that isn't like a challenge question. I prefer it, but if this is what people want to talk about, then I'll at least try it. Um, I want to figure out what function I'm thinking of for number two. So I definitely have seen the answer. Function that, I mean, maybe let's not Google it so directly. Let me just look up Dirichlet function. So I think it's gonna show up in the related functions. Really, one seemed kind of tedious with the idea that I had. Oh, this is not the function I was thinking of. The popcorn function, that's kind of fun. Stars over Babylon, that's a cool name. That's the function that I'm thinking of, color cone, yeah. Cantor? No. Ooh. Wait, these all look kind of fun. I'm gonna get distracted. I wonder what Euclid's orchard is. I am on the side quest. What is the significance of this? Oh, wait, these are different. Wait, what? If this is the definition, how are they different heights? Is that just communicating distance from the observer, I guess? The trees. Oh, okay, wait. I think. Okay. I think I sort of understand why this picture would look like this then. That's kind of cool. I don't know how this is useful for anything. It's probably not. Okay. I also want to look at Volterra's function. Differentiable, derivative is bounded, but not integrable. Differentiable, but not. Wow. What the hell? Oh, it's one of these things. It's not integrable? Why not? I guess they're gonna make me try to integrate it, and I don't want to. Okay, I'm just gonna believe them. What's the name of the function that I am thinking of? Function that is continuous at one point. I'm just gonna Google it straight up. Because I know this is the answer. I want to know the name of it. Maybe it doesn't have a name. Maybe that's the issue. It doesn't. Oh, that's kind of cool. I thought that was a Wikipedia page. That's just generally continuous functions. What if it would have this? Never mind. Okay. Anyway, um, man, it's only 2 hours in, and I'm already like yawning a lot. Okay. I think for number 2 we can just go straight to endpoints. If you want n many, well, I guess we can do f sub j. Why not? No, f sub k. Um, x minus k for x in rationals. What was it? 1? Or no, 0. Oh, well, we need to be x in rationals intersect. What am I trying to do with this? I'm trying to basically make a piecewise. Okay, maybe I think there's a can be a better, more compact way of doing this, but it's equal to x for x in rationals intersect minus 1 1 even. X minus 1 for x in rationals, or I guess x. Ugh. There's probably a cleaner way of doing this. Intersect 1/2, 3/2. This is basically my idea for an arbitrary number of points. Um oh, I would like to Fembox. My life once I graduate is gonna, I don't know what it's gonna be like though. Because I really like life in Seattle. I like to stay here, but if I want to stay here, I need to get a job here. And the lease on my apartment is gonna end at the end of July. So if my landlord isn't willing to extend, I'd have to find a job really quickly. And finding a job at all will be kind of, I'm not optimistic that I would be able to find one. So I don't know. There's gonna be a lot of things. Also, I graduate in mid-June, so there's not a lot of wiggle room, I guess. So not another reading group anytime soon, but depending on how my life shakes out after graduation, it'd be nice, but X and Q. Oh, you can get it all into one? Oh, yeah, yeah. I think that works. That's yours is a lot cleaner for sure, color cone. But yeah. Yeah, so like I've thought about that, and like if I were to a reading group, the things that come to mind for me are measure theory, functional analysis. Probably not though, because I think you need measure theory first. Advanced linear algebra, applied graph theory, and I want to throw in like astrophysics, something that's like more fun. I think those are things I'd be like the most interested in doing a reading group on if I did one. But I don't know. The first two I got interested in because they've been coming up a surprising amount, like way more than I thought they would for applied math. So it'd be nice to at least have like a little base of knowledge in those things. And graph theory I got interested in because like um machine learning graph theory actually like comes up in that for how you can cluster like the way that I want to like talk about this because it's actually like really cool. If you want to cluster data, which is hey Skirtle, let's say you have two dimensions, x1, x2, and you have like nice and clean data that looks like you have one cluster of data over here, and you have another cluster of data over here. You want to, if you weren't given these different colors that are basically your labels for the data, you want a way to like basically group these two clusters into two if you weren't already like, this is like the real answer, that the data that you're given in an actual application is like the uncolored data. And so for a really clean situation like this, there's an algorithm called k-means clustering where you basically guess two different means for each of these clusters. So like imagine like an initial guess here and an initial guess here. You make some like radius around each of these that defines your clusters, or you do it based off like whichever the nearest mean is. And then you can like iterate and make a better guess each time. But this the algorithm is going to fail if your data has an interesting shape. And one of the most famous ones is the half moon data set. So if your data is instead more like this, where they have an obvious like trend, but just kind of like a naive clustering algorithm can't deal with a shape like this. You're going to get like one cluster that goes like this, and another cluster that goes like that. And it turns out they can do some through the magic of graph theory. You can basically connect all these data points with edges. And you weight them according to their, well, you can weight them according to different things, but we just use like Euclidean distance. And then you can get an adjacency matrix out of that. And then you can use the power of linear algebra to basically transforms sorry, these are all like connected across here too. I shouldn't like, you basically transform them into a different space, x1 prime, x2 prime, where the clusters follow some nicer trend, or they're like separated in some way. So I don't know exactly like how it would look, but like you can actually like spread them apart just using linear algebra and getting their eigenvalue decompositions. It's apparently even related to like the heat equation and random walks and stuff too. It's me out here in Dublin. You're in Dublin? That's awesome. Well, sleep well. Thanks for being here. Thanks again for the help with the solids of revolution. Color cone for function analysis. There's a lot you can get into. Pure function analysis, PD, or probability theory problems that come to mind. As I know some books to build functional analysis around that. Yeah, I definitely would want to lean towards the applied part of functional analysis, but it feels like a good thing to have a little base of knowledge about. Like our Hilbert spaces, that might be a measure theory thing where you get introduced to them, but like a Hilbert space is something that I'd like to get familiar with. And I assume that's either measure theory and or functional analysis where you're typically introduced. Oh, maybe, Obi. You know, that there's not a 0% chance. She'd be a cool person to meet. T10 Mac or TO Mac, maybe? Complexity. That's a really good question. I didn't learn what the complexity was. It's not going to be quick. I can promise you that. O(n) squared sounds about right. Before you get arrested. I read it something along the lines of O(n) squared. It might be n log n because You can make it so your adjacency matrix or your adjacency matrix your adjacency matrix is always symmetric. So for computing the eigenvalue decomposition, you can use some quicker algorithms. And oh yeah, so for sorry, I'm trying to think about this. So there's two steps in this. One of them is computing. It's called a feature map. That's more of your pre-processing that splits your data up and makes it easier to cluster it. That's the thing that I was talking about. That it might just be n log n. It might be n squared. I'm not sure exactly. Oh, that sucks, Obi. But yeah, you need to compute using some measure for distance. That's probably n squared actually. You need to compute some measure of distance between every pair of nodes, which is going to be a lot. And then with that symmetric matrix, you need its eigenvalue decomposition, which shouldn't be the slow step. But then the actual clustering step is supposed to be pretty quick because of our pre-processing. So it's probably theoretically a pretty high upper bound like n squared, but in reality, it's probably not usually going to take that much if your feature map is a good one. I'm not an expert on this stuff. I've just been introduced to it, but that's my understanding. It's functional analysis where you should get introduced to Hilbert spaces. Some come from measure theory situations. Okay. Hilbert spaces are introduced to talk about Fourier series. Okay. Yeah, it's basically how I got introduced to them in the context of this like machine learning class actually. We got as we talk about like Fourier series are an example of like just a regular Hilbert space, but also we're talking about for ridge regression a reproducing kernel Hilbert space. I want to say it's called RKHS, yeah. Where the kernel has a specific property that I have to get my notebook to remember. But yeah, Hilbert space is where the kernel's a certain property that kind of enables ridge regression for machine learning. You know what? I want to find it. Reproducing property. I have no clue what this means right now. Wait. I think the property is f. The inner product of f with the kernel is equal to f. I forget what this means though. Function will let evaluate the function at a point is bounded. That might be an equivalent way of saying it or something, but this is the way that we were shown it. Okay. Yeah, actually, I have my VS Code open. Let me see if I have this sample code file open, because I thought it was really neat. Spectral clustering. Alright, so this is related to what I was doing up here. I'm about to show. Not that. Not that. That. Let me scroll up. The Recez representation theorem. The function is represented by a kernel K. Okay. So this is like that half moon dataset that I was talking about. On the left are like is the right answer. The right is the data that we're given in like a real world scenario. We don't know what the labels are supposed to be. For this, we're using a weight function that's just, if it's within a certain distance, you connect them with an edge. Otherwise, you don't. You can do one where the graph is entirely connected using this like Gaussian. And you just get really weak edges if they're far apart. And then you need to compute something called the graph Laplacian, which has, it's basically the, it's basically, but not quite, the discretized version of the Laplacian operator for like the second derivative in higher dimensions. And with that graph Laplacian, where do we do it? It's just the weight matrix. Oh, I guess before we even get to the graph Laplacian, if you can actually visualize the weight matrix that we made there, which I think this graph is kind of cool. Yeah, this is the unnormalized graph Laplacian. There's also a normalized and there's a random walk. One, it's called that because it's related to random walks. Like the unnormalized is kind of like the default one, I guess, or like the first one that you learn about. But yeah, so you get the eigendecomposition for that, and that becomes your feature map, or like that. It basically separates your clusters into different directions because I think because it's a symmetric matrix, which linear algebra tells you that a symmetric matrix has orthogonal eigenvectors. And we're using those orthogonal eigenvectors to like map our data points. I forget the exact details of how you do this, but like a y, but yeah, right, and real eigenvalues. Basically the point is that you can see two separate like moons now that have some distance between them. It is also in like higher dimension. We were just looking at 2 dimensions before. But yeah, the point is that it gives you like separation between your clusters. And the magical thing is that you only use the data that you were given to find the separation, really. And then now that you have that separation, you can do a regular k-means clustering that would have otherwise like failed. And you get like really good results. There's only like one little error there. That's not a big deal. Yeah, I don't know why I got on this tangent. Oh, because I was talking about reading groups. The fundamental theorem of undergrad math? Oh, that a symmetric matrix has real eigenvalues and orthogonal eigenvectors? Ugh. You're just doing stuff for that syntax error? I mean, apparently it's really important. It didn't come up for me all that much, I don't think, until this. Um, yeah, when I was doing the write up for the homework assignment that was related to this, I had to think about it for a long time for why this would give you separation, and that's the reason that I came up with. I hope it's right. I did score well on it, so. It's helpful in machine learning for one, syntax. It's helpful in a bunch of other things too, I bet. But I mean, no, Femox, I'm here for the yap. Um, I think the stuff I learned in this class is really interesting. I didn't get to share much of it during the quarter, so not going to be a machine teacher. I'm sure it comes up in other parts of math too. Just linear algebra is kind of everywhere, but yeah. So like that class on machine learning that I just took, or it wasn't just machine learning, but that was part of it. I didn't think I would like it, but it's turned into one of my favorite classes, and so like that's a big reason why a lot of these things are on this list for things that I'd be interested in doing reading groups on. Oh, I need some water. 1 second. Uh, no, I've never done a Lebesgue integral. I've kind of loosely looked into what they are, but I don't really know. They do all sound hard. they they definitely do. But I don't know. Like I'm open to other things too. Like if I actually went to run a reading group, I'd ask for like suggestions for other topics. So if you have something you even want to like throw out now, feel free to do it. Also, because I opened up my notebook and I saw it, I just want to rant for a second about a question on one of my finals, which okay. I had to draw this. Oh, you're not gonna be able to see it that well. I had to draw this contour plot, like right there. You can't see that well, but basically we had to freehand draw a contour plot on a 2-hour final when that was just like a really small part of the question, and I was really mad about it. You can't really see that well on the camera, unfortunately, because I most of it is in pencil. But yeah, I drawing a contour plot in a final is just ridiculous, I think. And it's a yeah. They ended up being hyperbolas. But if you do it wrong, you're screwed on the entire question. So it's really important. And it's easy to like mess up. Our old friends, I don't know if they're my friend. Yeah, that was for a method of steepest descent for like an asymptotic approximation for an integral. It's the same type of question as I was working on the last time I did a math stream. Which I still want to work out this question. I don't think I'm going to try to work on it this stream. Yeah, I made some nicer looking like contour plots after that stream. It's kind of a weird one though. I need to remember like how this works. Okay, what are we gonna do now? We've answered one of Papadoria's questions. It's not like for one, this is simpler. There's a relatively simple idea that I haven't thought of. Is it based on the slope of the tangent line that determines your maximum angle of rotation? Follow your nose. Should be something with the slope of the function. The reason I was thinking it would get tricky is that how do you rotate a function? Like I'm thinking you need to use linear algebra, but it's going to get kind of messy. Find extreme values on the derivative, use them to find restrictions on theta. What is it about? Why is it where the slope is the steepest? That's the first part that's going to fail? I keep drawing my graphs too small. So if I have a function, okay, wait. If I have like a sigmoid function, just where like the slope isn't very high, like the slope is like clearly at a maximum around 0 is what I'm trying to engineer here. If we well, actually no, this one you can rotate it by any amount and it's never fails. Doesn't say the function is differentiable. That's a fair point, Aeneas. I guess I think I want to focus on the simpler case where it's differentiable though first. Gamma sub f equals x f of x, such that x and r be the graph of f. Point of the graph given by x f of x. Now apply a rotation matrix to it. Okay, just far enough so you still pass the vertical line test. Right. What is color cone saying with this? Wait, how does the rotation matrix go again? I need to Google it. Oh, I was right with the cosine bit. Oh, that's I didn't know it had that relationship. There's probably a reason for that. Yeah, this is like Euler's identity, and that's like the derivative of Euler's identity. If that's the real part and that's the imaginary part. Well, no, never mind. I said that wrong. I don't know. You have to transpose it for that last part to be true. How do you do this with linear algebra? That like, do we? I feel like it'd be something with like the null space not being trivial. First coordinate, x cosine theta. Sure. And I guess the condition is we don't want. Hmm. Yeah, the Aeneas does raise a very good point about the differentiability. I guess this linear algebra argument from color cone doesn't seem to rely on that yet. Uh, so okay, so this is the first coordinate of the transformed. We don't want 2.2 have the same. We don't want 2 points to have the same first coordinate. That's the vertical line test. Right? Do we need like an x1 and x2 then? Or like I don't know. The music stopped, by the way. You know, let's play the song because Fembox it is around. Turn it up a little bit. Hopefully, I'll remember to turn it down after. Yes. Okay. You can choose an arbitrary rational number r in 0 pi over 2. Construct a piecewise function. Ooh. Probably it's a little bit too loud. There's no remove by 1 on the x-axis. Move linearly at angle r mod pi over 2. How do you mod an irrational number? I'm not sure what you mean by that, Aeneas. Um, so yeah, we do need x1. We want to make sure there's no x1, x2 such that We want this relation to be true for all x1, x2. Dr. Cook. I'm sad that I know what that means. Mostly. I don't remember. I was probably in bed. Are you on spring break? Put everything on one side? Uh... No, you're not? Oh, okay. Well, there's a tangent. There's a slope of a line. No, there's not. Never mind. There's almost a tan theta equals. Well, no. Yes, there is. That. Yes. Don't we have? Or do I have this flipped? Yeah, I'm about to like finish break and go into the next quarter on Monday. Yeah, it is cotangent. I have it flipped. What does that mean? I'm not sure what part you mean, Thunder. Sorry. I forgot what context you said that in. Oh, what that means. What's his name? Clavicular is a. I I almost don't even want to describe him, but he was just in the news because he got arrested, and he's an internet person. Uh oh, okay, no worries, Max. He does something called looks maxing, which is like it's like an internet movement where you stop at nothing to look better, including doing things like steroids or like doing sketchy, unscientific things to your body that are probably just hurting you and not helping you. So yeah, he seems like a pretty toxic influence, but he was in the news for getting arrested. You mod an irrational number r and a number selecting the least x. I guess Aeneas. I R must be irrational though, right? I, I don't know if I want to look at this cook. Yeah, it's about clavicular. I'd rather not look at that. I'm just gonna get sad. But it's a multiple fiber two. But yeah, I guess there's still gonna be like something irrational in there, which is like throwing me off with mod. Um, we're definitely math maxing. Yeah. Mog. I think it's when you like show someone up. I don't know what frame mogging is, I guess, but maybe someone else took over a video he was making or something and got in frame. But like it's when you like outdo someone in some way, I think. If you mog someone. So I think if you looks mog someone, you look better than them, or if you whatever mog someone, you are whatever better than them. Uh, so I like Colorcon's argument here because we haven't used anything with derivatives, which would also address Aeneas's concern. I'm still trying to figure out what we do with this though, with this condition. Like we want a maximum angle, right? I guess the maximum angle will be inverse cotangent of that. But well, what is x1 and x2? Mega, the stream is still derivative? It is. Pi over 2 plus pi over 3 mod pi over 2 is pi over 3. Okay, yeah, so I'm just not used to using mod with irrational stuff, and that's why I'm getting like tripped up. um Oh, is that an Aussie band? That's cool. So, okay, if cotangent looks like that, right? So inverse cotangent is gonna look like that. Um, I want to name an x1 and x2. I think we're missing that. So like we need to do some type of like bounding, I want to say. Or something. Want theta to be a valid angle, so we want theta not in. Would it be not in? Wait, I mean, I guess uh theta. I guess we're only when as soon as we take cotangent of theta, we can only consider whatchamacallit. We have like the vertical asymptotes. Do we care about a rotation of more than pi? Probably not. Um so I don't think we have to worry about discontinuities on the left side, but we do. I guess, and we. Oh, but I don't know. For sine theta going to 0. Yeah, sure. Syntax. The person who asked this question on screen isn't even here, so I don't mind just talking about your question. Yeah, right. I realize that we don't have to worry about that being 0 ever. If these are equal, there is no value of theta that makes that true. Um, Which would that be right? Like, so I like one of the first examples I was thinking about with this question was a parabola. And I think with a parabola, there is no rotation you can do that's valid here. So that maybe that's an okay condition to have. Oh, okay, no worries. Syntax. Uh, Tiomac, you can certainly ask. My like preference is to work on like homework questions because to be honest, I'm just not that good at like the creative type of math questions. So those are always my priority. But like at moments like right now, there's someone who's asking a question, so I don't mind kind of doing whatever. I can't promise that I can figure your question out or even say that much about it, but you're always welcome to ask it. You can have all possible slopes on the parabola. Sounds good. Tiomac, by choosing x1. Yes. Oh yeah, and so I guess like it like at least it seems like it needs to pass a horizontal line test, I guess, in order to be rotatable at all. Like if we chopped off the left half, we can rotate it any which way. And I think we're always fine. But as soon as we don't pass a horizontal line test, I think we're in trouble. Yeah, because if I didn't chop it off, I could always choose 2 points that are at the same height. So the right side would be 0, and there is no value of theta that cotangent is 0. Wait, that's a lie. I just lied. I don't know. Never mind. I'm making shit up. um I was getting mixed up with arc cotangent, I think. So yeah, cotangent theta, that can take pretty much any value for theta between 0 and pi. And a parabola can also take any value for that slope. You just choose your points accordingly. So I don't know what I'm doing with this example. Well, okay, I still feel like you can't rotate this parabola though. Like it there is no way you can rotate this parabola even like a fraction of a degree. You're still going to get something that's not a function if it goes off to infinity. I still believe that. I don't know how to express that in this language. If we have a portion of a parabola, like let's pretend we cut it off like this. Can we rotate this even? It's hard to I feel like we can, but it might just be because of how I've drawn it. Maybe you can. You probably can. And I bet that secant line has something to do with the answer. I don't know. The maximized slope is to start from the origin. With a parabola, I think you always get the best slope if you have 2 points really close to each other at the end. Okay, yeah. I'm trying to visualize rotating this. If we rotate it, do we run into issues? Like, so I'm imagining a counterclockwise rotation. Do we maybe run into issues with this portion of the graph first? Or I guess just the bottom in general. I don't know. It's really hard to think about this. The origin fixes my idea. Sure, you cannot rotate the whole parabola by any angle that aren't 0 or pi. Okay. Cool. I don't know. Papadhoria apparently has the answers, or it's some sort of answer for all of these questions. For the whole parabola, consider f(x) equals x squared over x. This is the slope between the origin and a point on the parabola, any arbitrary point. I agree with that, yep. If x equals x extends to 0 at the origin. Like it is 0 at the origin? I would agree with that. X equals cotangent theta gives us what we want. That's why we can't rotate the parabola by any angle when you don't cut it off. Like I did. Okay, so I don't understand why this gives us what we want. You're talking about the slope of the line from the origin to some arbitrary point on the parabola. The slope of that line is just x. And you're saying if we let x be cotangent theta, we get what we want. That's the part that I don't know why that's true. And I don't know why that gives us... Yeah. Which we found tells us the slope shouldn't be cotangent theta. Oh. Well, so then how do we know this x is cotangent theta then? I see the last part of the argument now. I see the second to last part. Theta is the angle of rotation. Cotangent of that angle is adjacent. It's like if our angle of rotation is like that theta there. Right. Color cone, yeah. Hmm. Our condition we know it's only possible when the slope for 2 points x1, x2 isn't cotangent theta. Oh, okay. I think I see what you mean. Because we can always find an x such that... Okay. Yeah, because the parabola does go off to infinity, we can always engineer it so that we find an x value that's equal to cotangent theta. Okay. Oh, true, yeah, and you just... Okay. I see now. Thank you. That makes sense. Okay. So we can make this work for that example. I I guess this condition isn't answered to the question because the only thing we're given is continuous, and I'm not sure we can say much more. Okay, that's fair. I I feel like we need to go farther, but I guess not. Okay. We don't even need continuous. Oh, that's true, yeah. It'd probably be very difficult to get an actual angle theta, but the same thing would still hold. Yeah, yeah. I think that was my hesitation with saying this is the answer, which is it'd be very impractical for functions that aren't differentiable, much less continuous. But I think it's the most that you can say without more information. Okay. Yeah, exactly. Like we would need more conditions on F. Max is saying theta is valid if and only if there are no 2 points such that the line between them is vertical after rotation by theta. There does not exist in x1 not equal to x2 such that sure. May need to change the sign in front of theta depending on which direction. Yeah, there's a little like I am only considering rotations between 0 and pi with this argument. I don't think it's the biggest deal in the world. Fair enough, Max. If f prime range over all of R, we can never rotate it. So for any theta 0 or not pi, that's already known to be valid rotations. Sure, yeah. If f prime ranges over all of R. I think we might only need f prime ranging over half of R, like from 0 to R. Because we can always reverse the order of these 2 points to flip the sign. I think. I don't know. What if f prime is bounded? Yeah, Aeneas, that might be the spirit of what Papadhoria was asking this question in. I guess if oh yeah, never mind. M couldn't equal 0 with the way that you phrased it. But yeah, if you're given a bounded f prime, you can probably say something more. And of course continuous and differentiable and all that. That's kind of challenging. If f prime is bounded. And I think that's what Finbox was saying too when we were first reading this question, like looking at the maximum value of f prime. Like that does feel like what you need just intuitively, but I have a hard time figuring out why. because I can definitely name a function, like any type of sigmoid function you could that has a bounded derivative, and you can rotate it by any amount that you want. So as long as it doesn't go like vertical, which even though that might not be an issue. I guess that wouldn't be an issue at all. Hey, Dessen. So you probably need a stronger condition than just a bounded derivative if you want to set a maximum. I don't know what it will be though. I am the bounded derivative. Yeah, that's me. I don't know. I want to read number 3, I think. Should be rotatable by theta. Cotangent theta outside 0, comma m. Oh, maybe, I guess you could guarantee like a minimum amount of rotation. Rotate these nuts. Hello, Vasan. Hmm. That if I were to just guess the answer, Aeneas, that would be my guess too. That there's a relationship between cotangent theta and the maximum slope. I don't really know how you actually show that, to be honest, though. I can feel my brain kind of fading, so I want to at least read 3 and see what's up, and I also want to type out a response to Papadhoria, or at least what we have done. Cotangent theta is a criterion. Yeah, but like, so the criterion we found is that if there's any pair of points such that this is, or if there's any pair of x1, x2 such that they are equal, then it's not valid. So as long as they're not equal, you're valid. So, but you could do like you can convert it to like a less than or greater than strictly to assure yourself of that. The quotient. Oh, you probably do that with like an extreme value theorem type of thing. Or mean value theorem, rather. Oh, yeah, yeah. It must be mean value theorem, right? I still don't have like a super rigorous answer for this, but I think we have the pieces of the puzzle here. It is basically all the same thing, yeah. Actually, yeah, I think I could answer this then, yeah. People try to get their PhDs in the 1800s. I mean, I kind of assumed a lot of them were mostly discovered by the same person. Maybe not, though. You can control that magnitude using the bound on the derivative. Okay. Oh, wait, well, mean value theorem might not be enough. I forgot, mean value theorem doesn't, like, you could have, if, like, that's one endpoint, that's your other endpoint, you could still have some crazy function like that. But there's something in there. I don't know. Magnitude f of x2 minus f of x1 is equal to the integral x1 to x2 f prime t. Oh. Oh, interesting color cone. That's cool. I like that. Oh, Dessen. It's a problem from Papadhoria, who's known to have like interesting and challenging questions. Um, that's the one that we're talking about right now. And so we found a condition for functions in general, and then we've narrowed it down to differentiable functions with a bounded derivative. Just to try and make a stronger statement. Yeah, let's write out what color cone is saying. And then we can bound f prime above by m. Yeah, Destin, I still don't get the intuition quite for why, but it does feel right to me at least. Triangular inequality for integral. Do we even need the triangle? I don't think we need the triangular. Oh, I guess we did. I should have moved my absolute value signs then, maybe. Uh, yeah, I do need to. It's fine. There's a slight error in my work with these absolute value bars, but I think it's not wrong either. Actually, yeah, it's fine. It's a really important trick to know in analysis. You can use that to show the existence and uniqueness of ODEs. Ooh, oh, okay. We could even provide exact condition on theta if f prime is continuous. In terms of like inf soup. Ooh, really? So idea for bounded operators, derivatives, and the Frechet derivative. Ooh, I feel like I've barely learned about Frechet derivatives, or maybe I've looked them up before. I don't remember how they work though. Or Frechet, maybe, I don't know. Hmm. Okay. What does number 3 say? I'll put it in the Twitch chat too for the benefit of mobile people because Papadori posted a few questions. I don't I don't understand what 4 is even asking. I don't know what capital D is or capital A is or capital R, I guess. But for, at least for 3, row conditions of a continuous function f of x have a fixed point iteration. Where f of x is does limit as n goes to infinity x sub n, where x sub n plus 1 equals f of x sub n. Uh, Is x a function? I guess it must be a sequence of functions. I don't understand this iteration, actually. I don't know what this means. If x sub 1 is just the original function... Oh, domain and range. That could be it. Usual condition that f must be satisfied. There's some typo. What? When does the fixed point method converge? Iteration is in like Newton-like operators? I don't know what that would be either. Locally contraction map. You're not addicted to fortune cookies? A smile is your personal welcome mat. That there's something about that that feels a little bit off. Like calling your smile a welcome mat, like people are supposed to step on you. I don't know. Don't let people step on your smile, Clonk. Question's a bit ambiguous. Yeah, I think these are questions that Papadhoria just kind of like invented on his own. So that's analysis. Yeah, to be honest, I don't understand what the iteration actually is. I don't want to stream for like that much longer either. Let's if D is domain and R is range and number 4. What's the domain of that function? Actually, let me put number 4 in chat also. I did change my Napoleon haircut, yes. Now, Mr. Buzzcut. So, the domain of this is defined by this. I'm dumb. So we want this to be a positive number or a 0. Oops. So if we just hold x greater than 0, then we also need ax plus 1 greater than 0. So x is greater than minus 1 over a. Which a could be positive or negative as far as we know. Or 0. But probably don't need to consider 0. Well, probably do. If x is less than 0, ax plus 1 should also be less than 0. I haven't listened to this song in a minute. Holy crap. Yeah, JC. Um, of the Fray. I gotta Google this. The Fray sounds familiar. I forget what song I would know them from. How to Save a Life. Okay. Oh, my computer is slowing down. So I think we can all know, based off what Dustin said, who the lead singer is. His hair, I think, is significantly shorter. Oh, okay. Well, let's see what it looks like in the music video, though. So that's he's just like straight up bald in that one. Okay, actually, yeah, JC, you're absolutely right. It's not far off. Come on, give us a good shot. Oh, I think his hair is still shorter, but not by that much. So I can see that, Dessen. Also, dude, get rid of these sideburns. Oh my god. Um, you think I'd look good bald? I don't know. That's a scary thing to go all the way. I already like I only like I didn't go any shorter than I already did because I already noticed I have like a weird like pimple on my head like right around here, and I'm afraid there's gonna be like more if I or I'm gonna like notice more of them if I went like all the way bald. Okay, but if A is positive, then X has to be greater than 0. We should just do this in Desmos. This would be so much easier. Ooh. Interesting. Okay. Oh. Ooh. This is kind of fun. I don't know why I think this is fun, but I think it's fun. Okay, anyway. Did I get into casting for some Breaking Bad sequel? That will be great. I would love that. Unfortunately, I just did this for free. One or two pimples, especially on the back of my head when I get a haircut. Probably, ooh, maybe, yeah. I think I've had this one for a long time, though. I just haven't really, like, noticed it. Look at the tattoo on my face? No! Also, like a pirate? Oh my god, that's a hard... I'm not getting a face tattoo. So if A is positive, um, the domain is 0, infinity, union minus infinity, minus 1 over A. Inclusive? Probably inclusive. A Mike Tyson tattoo? Like a tattoo of Mike Tyson? I don't I don't want a tattoo of Mike Tyson. Or does he have a tattoo that I should copy, is what you're saying? A line under my ear? What? No. Did it? I didn't hear about that. Wait, Mike Tyson has a... I didn't know he has a face tattoo? Wow, I don't know how I never noticed that. He has a face tattoo. I think I'm okay. I wonder what it means, though. Controversial reason. Tribal tattoo on his face to avoid fighting late in his career. But a math equation? No. This is a terrible idea. Why would a tattoo prevent you from fighting? If it's fresh, sure. Oh, that... I guess because it was fresh. Okay. Wow. That's a hell of a way to get out of a fight. Getting a face tattoo. The hyperbola ellipse thing, conic sections? Oh, probably. Yeah. It's an ellipse for negative A. Hyperbola for positive A. That makes sense. Like an exclamation mark on my forehead, Dawn Factorial. Put a fat integral symbol tattoo. The YouTuber... Does he have a face tattoo? If I just YouTube Tom Math Cambridge, will he come up? Tom rocks math. I don't see a face tattoo. He does have a unique look, though. I'll give him that. Also, he has way more hair. He has like 100 times the hair that I do. Diagonal slice of a cone? Yeah. Oh, that's for Destin on his forehead? Yeah, Destin, you get that, then I'll get a I'll get a face tattoo. I don't even know what it was. If I had a... Now that's a good question. If I did get a math tattoo, what would it be? Hmm. I don't think I found the right thing yet. Like, a fractal would be like pretty low hanging fruit, or like it's kind of like the obvious thing, I think. Um, I was thinking like a PDE could be cool, like the heat equation or something. Um, it'd be the word math, Ren. You know, it's simple, and they say keep it simple, stupid. So I respect that. It would take forever to draw max, literally. You'd have Kid Grothendieck on your arm? Is there a childhood picture of Grothendieck? Oh, that's a different Grothendieck. Wait. Oh. Yeah, that's actually a pretty clean look. That's not him as a kid, obviously, but... Oh, those are his parents. He has a pretty crazy, like, life story. Like, this is a good Wikipedia read, if anyone is ever bored. I don't see any childhood pictures on his Wikipedia page, at least. Get a tattoo of yourself with a tattoo of yourself fractal. There you go. The cover of a book as a tattoo? A lot of math textbooks have really lame covers. I see early math is fun. A little on the nose, but I respect it. I don't know. Hmm. Honestly, maybe a physics thing too. Like Maxwell's equations would be a pretty like badass thing. Um, well, no, badass is the wrong word. It'd be very nerdy. Do you just mean this? That was fun, but in Comic Sans. The Rising Sea. I remember you talking about a book. I think with Slim. Yeah, that's a cool cover. It's a cool painting. A yellow background with graduate textbook in mathematics. I mean, honestly, that would do it. I guess that's the youngest one of him in these three. I don't now Grothendieck. There's no way Grothendieck has kids. So like, who is this baby? There is one as a kid. I don't see it, but he had a lot of kids. Oh, never mind. Okay, and a lot of wives. Okay, that too left as an exercise for the viewer. Oh God, yeah, Tiamat. I completely forgot you were doing that. Yeah, hit me with it. That's good timing. So I was planning to not stream for that much longer anyway, and I would have felt bad if I just ended it without even seeing it. When his wives went to your university. Oh, that, that's cool. You know, there's a lot of bad. There's a lot of mathematicians who are bad fathers. That's not super surprising. Oh gosh. Okay, we got a three-parter here. So if I can actually say something about this. What if kids ran away and didn't care that much? Oh no. Okay, it's applied to a set of S unique identities. Wait, I already feel like I'm... Okay, never mind. Give me a set of values. I already don't know what it is, but it is applied to a set S of unique identities. It can be a set of values, vectors, matrices, geometric bodies, Einstein tiles, anything we like. There are only two limitations. Computers can store it precisely, efficiently. Plain rational numbers won't work out. We or a computer can construct pseudo-random values of this set independently of another member of this set. Will XY be two members of this set, and FG be two distinct bijective functions which operate on members of this set. XY be two members of the set, FG be two distinct bijective functions which operate on members of this set. And they commute with respect to function composition, but they aren't the same function. For most or all cases, we can be creative about f and g. Now we assume that we can apply fg multiple times on x to reach y at some point. Do the condition on top, we can formulate it. Y equals f to the n g to the mx. Sure. You can apply fn times and gm times on x to reach y. Which kind of set identities and functions can we use that finding m and n is complicated, just applying f or g is simple? We can only find it by testing around. Complicated means. For random x and y this set of the set S, it should take significantly longer than square root S. More like I mean S over 2. Huh. If you had something in math named after me, what area of math would I like it to be? I mean, I guess whatever my favorite area of math is, like dynamical systems or PDs or something. But I feel like trying to get something named after you is kind of vain, and mathematicians shouldn't try to do that. I don't know. But the entire thing of like having it a goal to get something named after yourself just feels very like self-centered. It does kind of have that flavor, right, Aeneas? Oh, and the answer is yes. You're really good with dynamical systems? Okay. I mean, it'd be cool to use like grad school as an excuse to travel. I don't know if I have it in me to apply to grad schools again, but it's cool to hear. GGG, you're so drunk. Congratulations. Hope you enjoy it. Remember to drink some water. F and G commute seems to restrict them by a lot. So S needs to have two independent axes slash parts. Yeah, that is a good point. Like, because my mind immediately goes to like linear algebra. I know that if it is a linear algebra problem, it's never going to fulfill this last condition down here. Because, or at least like, you know, because I mean, no, not necessarily, but just like, well, probably yes, because like you can always solve a system of equations by like taking the inverse matrix, or there's a lot of methods to solve a system of equations as quick as you can. Um, but just thinking about this in terms of linear algebra, just to have something to start with, like the two functions commuting would correspond to matrix multiplication commuting, which it can be kind of hard to find transformations. I imagine it's, well, no, it depends what type of transformations, I guess, but I guess you could do like rotation matrices. Those would commute. It's regardless, it wouldn't be a good answer. Cook. Is that right? When I was 0 years old, YouTube held that one for review. They'll talk with professors if you want to apply to any private company. I don't think that's true. Or what do you mean? Like, talk to professors at my current university when I go to apply to a random private company? Commuting just, I think we want, it doesn't have to commute, but if it does commute, it makes it possible to make this much simpler statement. I think the problem would just be way more complicated if they didn't commute. So, like, I've been trying to think of like things that would satisfy this, just like in terms of like I think the right way to think about this is some type of like geometric thing. Like two rotations can commute with each other, but we want something more complicated than a rotation. Choose a sequence of powers if it's not too large. I guess so, but oh yeah, Anakin Luke. Like it's always so cool to hear like what countries people are from. So, or I wouldn't say there's always I it is like I think mostly Americans looking at my stats, but it's like only up to like 50 or 60%. And then were some huge numbers that wouldn't work, right? Hmm. Oh my god. Oh. University of Tokyo. Oh, that would be such a nice excuse to go to Japan. That would be amazing. I have a feeling that you would need to know Japanese though, which I think you've mentioned that you at least know like a small amount of it. So maybe you'd have a leg up. Hmm. Kyoso Ito or Kiyoshi Ito? I don't know what that is. You're Japanese, you know, some basic restaurant and office phrases. That's more than me. Going to Japan, I guess a year and a half ago now, maybe want to learn it. But I still want to learn Spanish more, and I'm nowhere close to knowing Spanish. So oh yeah, Skirtle. Thank you. I'm glad you've always believed in my Spanish. You've never made fun of it. Honestly, Destin, if it wouldn't slow down the stream with me always opening up Google Translate, I actually think that's kind of fun. Whenever I see people typing Spanish in someone else's chat, I like to see like what percent of the sentence I can figure out without Google Translate. Thank you, Skirtle. Yeah. I really pride myself on pronouncing Spanish with a really authentic accent. And yet, Anakin, like AI is definitely like a scary thing there. But the thing that I tell myself is that everyone's going to have the same issue with AI, so hopefully there's going to be some solution. But like, I also don't blame you for um letting that affect your path. As if I'm Spanish all along, yeah, yeah. I think Spanish is just like a beautiful language. Picky Masters. I was gonna type you up a message. We talked about. I kind of got distracted, but like we talked about one and two of your first two questions a lot. We talked a little bit about three and four. Um, I was gonna type you up a response, and I still will, or maybe we can like talk about it. I feel bad that Tiamat went through the trouble of posting this long question here, and I still like I feel like I haven't said anything helpful about it. And I've been trying to come up with like some type of idea here. For American standards, I think you have an English from England level of pronunciation, definitely not American. I hope that's a good thing, but it might not be a good thing. um, Immaculate and emasculate. Immaculate is like perfect. Emasculate is like when you don't feel like a man. I think. Um, Emasculate is done. Immaculate is on. You know? Thank you, Skirtle. One compliment, one insult. So yeah, Team Mac, I don't know. This feels like a research question, to be honest. Um, I can post it in my Discord though. I can't promise that someone will like be able to talk about it, but maybe someone will. I thank you for trying with me, but I do want to talk to Papadhoria about the questions that he posted. Um, okay, I just posted in my Discord now, just to see if anyone has an idea for it. Just to keep my ego bait. Thank you, Skirtle. You know, my ego gets out of control really easily without you here to keep it in check. Cash obviously antagonized, not to be confused with agonize. No, Skirtle's not Chilean. Skirtle's Filipina. I can't talk. From Chile to Brazil to study dynamical systems. Now some work in Universidad Católica. Going for grad. Okay. Difference between no and no. Dr. Cook. Apparently not. Yeah, so Tiamek, thank you for the question. I'm sorry I can't say more about this. It's an interesting question though. But yeah, I'm not sure I have anything to contribute here. Okay. Both terrorized by Spain? Fair enough. Okay, so Piggy Master / Papadhoria. I have been cooked, thank you. Why the Philippines is called the Philippines? I don't know. So for number one, so Philip, maybe it's Philip. Talking just about okay, yeah, called it because of King Philip. We'd start by talking about just functions in general, not even continuous functions. Collar Cone found like basically this argument here, which is if you represent the points of the function as x, f of x in a vector, you can multiply it with the rotation matrix. And if you keep just the first coordinate, because that's one that we care about for the vertical line test, it's x cosine theta minus f of x sine theta. And what we want to do is make sure that there's no like pair of points such that these two things are equal. So we made an x1 and x2 that are distinct. Like I didn't actually like write it here, but x1 is not equal to x2. We want to make sure that given two distinct inputs, these two quantities are different. And so if you shuffle things around, you can get this condition that cotangent of theta is it for any pair of x1, x2, this quantity here can't be equal to cotangent theta. If they are equal, then you don't have a function after the rotation. And I think that's the most you can say if you don't have any conditions on the function. And then we worked a little bit more on it after that. Let me catch up with chat though. If you look in the right places, you can find some good offerings. That's an alright fortune, Clunk. You make other people realize that there exist other beauties in the world. That does feel like an insult. Other people realize that there exist other. I mean, it feels a little backhanded, but I think it is ultimately calling you a beauty. Because it does say other beauties. I guess that would imply that you are one of the beauties, but I don't know. That does feel a little backhanded. You were given the chance to take part in an exciting adventure. It's an alright one. Hey, underscore. Your cookies fucking hate me. They kind of do, Skriddle. I don't know why. Yeah, underscore. Piggy Master in chat posted a series of questions. We're talking about this first one up here. Given a function, what angle can you rotate it by such that it's still a function? Hey, welcome back, Martin. I don't know why it says adult who set it up. Yeah, if name equals Skriddle underscore give insulting fortune. Also, I bet I could actually do that, and that'd be kind of funny. You're tempting me. Your keen sense of humor will make you many good friends. That's a good fortune. Okay. Why would that be underscore? 'Cause I thought what we did here was valid for NEF. A horse or a seahorse? Probably a horse, as long as I'm not, like, domesticated. Tattoo Ketsu wo Tabaru? I don't know who that is, or what that is. If name equals Skriddle, cookie fucking equals true. Martin, you can post it if you want. Okay, and so, then we modified the question to say if f has a... I didn't do a good job of, like, writing it out, but if f has a bounded derivative, capital M, I didn't quite actually write the argument out, to be honest. Oh yeah, I think we can guarantee that... Okay, no. I think the argument was, we started just by looking at this quantity here, f of x2 minus f of x1. Using the fundamental theorem of calculus, you can actually bound it. Or you can bound this quantity using the bound on the derivative and the fundamental theorem of calculus. So like f prime is bounded above by m. And so you basically, from this line and this line, is less than or equal to m. And I think that means that we want, as long as m is smaller than cotangent theta, we're in business. Or like we're guaranteed this condition is true. I think is what we said for a bounded derivative. Yeah. Martin, if you can fit it there in the YouTube chat, that works. Otherwise, put it in my Discord. Donkey Kong Country 2, I never played it, actually. Don't understand question 1. The angles can be different for different functions. What type of function are you restricting f to? Oh, this is... Or it's the same band, different song. This song is Acid Rain. I think that one is called Anvil. The band is Lorne. So yeah, Anakim, or do Luke, I don't know what I'm calling you, Anakim. It turns out that, like, it is going to be dependent on the function. Like, some functions... okay, I'm glad that either is fine. Some functions you just can't rotate at all. Some functions you can. What we did is we found the condition that kind of determines... whether you can rotate it by a given angle, depending on the function. It's not a very practical condition to actually find, but like you can still say like what the function should look like in order to be rotated by a certain angle. Can I host repo? Is the patch actually out? I need to catch up with chat. That bounded growth rate makes sense to limit how much rotation will affect the vertical line test. Should return a function, yeah, okay. F prime bounded implies fx2 is bounded by the mean value theorem, gives bounds on invalid theta. I thought the mean value theorem didn't necessarily bound the derivative, right? It just guarantees the derivative has a certain value. I think, but I don't know. Or that sorry, not that the derivative, but that quantity. It might not have the same bound. Maybe it has the scalar multiple of the bound. I don't know exactly though. I don't think I've seen the music video for Acid Rain. Yeah, so y equals x squared underscore is the exact one that we were thinking of. Or is the exact like type of example that we were kind of like playing around with. Okay, yeah, right. So, sorry, underscore, I misunderstood you. I agree. With x squared, you cannot rotate it at all unless you want to do a 180-degree rotation without making a function. But, so yeah, for a general function, you can't rotate it by any angle you want. But you can still say like what condition should be true if it can be rotated. So like I guess that's the question that we're trying to get at. These are just written by Piggy Master, aka Papadhoria, just kind of like for fun / curiosity. So there might be some like or the phrasing might not be exactly like precise, but we're trying to get to like the spirit of what's being asked. Phrase this in the following way. Where is the curve closest to flat? You can rotate the vertical line test back to the original graph, in which case the vertical line is a theta line. You want to know what's the largest theta line for your function? Yeah, cause I'm not completely comfortable with the visual interpretation of this, and I think it's something like what you're saying there, Dr. Cook. It's like, it makes sense that it should depend on this in some way, like that we get a result like this. I'm still not entirely comfortable with the entire journey of going from point A to point B, but I know it should look something like that. Flat / constant function, which must be rotated by 90 degrees. Oh, let me see. Okay. So yeah, Martin, I see you put the equation for a line in chat, but I don't see anything else that you've posted. Okay. See, that's what we talked about for number 1. For number 2, it's a possible function to be continuous at 1 point and nowhere else. What about 2 points, n points? Prove your answer rigorously. I didn't do the rigorously part, but I've heard of the answer to this question before, so I was a little bit spoiled on it. But the basis for the answer is like the function like where it's equal to x when x is rational and 0 when it's irrational. Fair enough, yeah. And so starting from that, you can extend it to an arbitrary number of points. I did it in this kind of sloppy piecewise way of just splitting up on different intervals. Collar Cone found a cleaner solution, which is x minus 1 minus 2 dot 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 x minus n when x is rational, and then 0 otherwise. So I think this is like a bit cleaner, but I think that they both work. The derivative overestimates the invalid angles by a bit, though, because fx equals x cubed has f prime 0 equals 0. There are no 2 points with secant 0. Yeah, x cubed, you can rotate it by any angle you want. I was thinking about that function before, too. There are no 2 points with secant 0. Oh. That's a good point. Yeah. I like that, Max. Yeah, Luke. Pigmaster is known for challenging but kind of cool questions. Even like f of x equals cosine x for rational x. Right, yeah. Well, that might be a little bit sloppy. Or wait. No, yeah, that's fine. That's fine. Yes? No. Um Cosine x for rational. X for irrational. Isn't that just around 1 point? I saw a function like that I think it was on a stack exchange thread. If you do like sine of pi x, if you want it to be around the integers, you can have infinitely many. Lipschitz continuous. Oh, yeah, that's probably what you want, underscore. Okay, fair enough. Papadhoria. Um, Martin, let me read your question. Equation line passing through a point of intersection lines A. Oh, that's kind of a funny question. We can do it. Just give me like a few more minutes to talk through these last few questions, if you don't mind, and then I'll work on your question, Martin. And then probably be the end of the stream, I think. So yeah, for number 3, Papadhoria, I don't understand what this fixed point iteration thing meant. I couldn't figure out what was happening here. Color cone, and maybe Aeneas were talking about this question, but I wasn't quite following the conversation. So I don't have much to say about 3 personally. 4, I started to work on. I'm assuming domain, D is domain and R is range. I started to work on it and then I got distracted. Oh, that makes right. F of F of F. Okay, I get it. It's composition. Okay, I don't think I would know what to do with or like how to do that anyway, but at least I understand what it's asking now. In D is domain and R is range. Okay. I did figure out the domain based on the sign of A. and using Desmos. Hey, Raven. Before values of A, does the domain equal the range? I'm not quite sure. We need to impose some kind of condition on it based on X or A that I would need to work out still. I do want to get to Martin's question. I can maybe come back to 3 and or 4 if someone wants to talk about it, but I don't keep Martin waiting for longer than I have. No worries. Thank you for posting them. I was gonna write you a message to reply, but I'm glad you popped back in so we can talk about them. And thank you for your patience with waiting too, because I remember I was distracted when you were originally asking. Your power went out. Oh no. Find the equation of line passing through. So these two lines intersect at a point, and we need to find the line connecting that intersection point and this other point here, as I understand the question. So this is like 2 problems in one. It's a little bit weird to ask it like this, but we can do it. I don't have an official queue. If you want, just go ahead and post it, and we'll talk about it after this. There's one else. I just have like a mental queue that I keep in my head, or if it gets crazy, I write it down on this page, but it's not usually a problem. You solve this, but you're having an issue? Okay, I guess I'll just try and solve it quickly then, so we can see what your issue is. And I won't explain as much as I normally would, unless you ask me to. So I would add these 2 equations, because I notice the y's are going to cancel. So 4x plus 4 equals 0, x equals -1. If x equals -1, I'll use that equation. Why not? -1 minus 2y plus 3 is 0. Does that mean y equals +1? Yeah. Okay. So we connect the points -1, 1 to align with -1, 0. Oh. This is a vertical line, isn't it? Yeah. So the issue that you're running into, do the y's minus the y's, 0 minus 1, the x minus the x, -1 minus -1. So yeah, that's the issue. We're gonna get 0 in the denominator. And so we need to like back up, and I would actually just graph these lines. Or I'm sorry, I would graph these points. So we have 1 point here. This is -1, 0. And we have 1 point here, -1, 1. These are connected by a perfectly vertical line. And so unfortunately, we won't be able to use point slope form, or at least not in the usual sense. When you just have a vertical line like this line is just x equals -1. I would say this is the answer to the question. X equals 1 defines a vertical line right at -1. Like, and if you had a horizontal line, this would be y equals 1 here. But since we have just a vertical line like this, like x equals -1 is the best that we can do. So, oh, well, that's the same thing. I could add 1 to each side of this equation. X plus 1 equals 0. I don't like it as much, but you can say that that's the answer too. No, so point slope form isn't valid for this question. So point slope form is something like this. We don't have an M that's legal to plug in. You have to do procedure? Well, the thing is, the procedure breaks down here. Like, there's nothing we can plug in for M. It wouldn't be correct to plug in 0. 0 gives you the wrong answer. I mean, I don't know what to tell you. You could flip things around and say 1 over M, y minus y0 is equal to x minus x0. Just divide each side by M. And this becomes 0 now. Like, we started with minus 1 over 0, but 1 over M is 0 over minus 1. So in this case, we're kind of like, we're saved, I guess. So we get 0 equals x minus minus 1. I think it's the best that I got for you if you have to use this procedure. I just wouldn't, but... I know. So yeah, if you really need work that uses this to write down, I would do this. But if you can't do that either, I really don't know what to tell you. And Luke, feel free to post your question whenever you can. You can put it in math discussion or homework help, whatever is easier. So yeah, Martin, I hope that that works, but I'm not sure what else to do there. No worries. Okay. So you posted it, Luke. Let's take a look at it. This is in Obi's chat a while ago. Curious if you have a different view. Found this on a real analysis textbook that is in the Epsilon-delta as a theorem rather than a definition. Really? Is this theorem ill-formed because there's no quantifier for x? Let's bring this into Journal++. Taking a pediatric analysis course starting Monday. Professor Lily said, my confusion is simply immeasurable, and I feel sad for those you will endure this class. No! How do you always end up in these classes? Good luck. Godspeed. Your analysis was your favorite subject, sadly you dropped out after that? Oh no. I thought, I'm glad you're getting back into it. Let's see if, we can figure this out for you. Will f be a real valued function whose domain is a subset of R? F is continuous at x0 in domain of f, if and only if. For each epsilon greater than 0, there exists delta greater than 0, such that for x in the domain of f, and x minus x naught less than delta, imply fx minus f of x naught less than epsilon. Yeah, this is this phrasing is a little bit weird because this really does seem like it should be a definition. Because if they're calling this a theorem, I feel like they've defined continuous somewhere else. Um, I assume they haven't. Yeah, sure, Luke. It wouldn't hurt. Links are turned on in chat, or you can put it in the Discord. I don't know these professors always end up being so scary. I guess I'm also not sure, Luke. There's no quantifier for x. Like, what quantifier do you mean? Like, we specified it's in the domain of f, and that has to be close enough to delta. So I'm not sure what else we would need to say about x. Oh yeah, Max, this is like the typical like math way to define continuity. It's yeah. Um yeah, I think it is just the definition. Should that be true for any? Oh, I guess but it's both of these conditions have to be true at the same time. So x needs to be in the domain and it needs to be within delta distance of your point of interest. So if you have, and the reason that they say those two conditions separately is a little bit weird, or is like it's a little bit like there's just like some edge cases that this definition is trying to take care of in a sneaky way. If I have a function that's like it's, let's just say it's defined on like 0, 1. Like it's not defined over the entire real line. Um, and let's say we're interested in like the continuity at this endpoint here. At I'm gonna let x not be 1 here. Um, x being in the domain of f means we don't need to consider x's around here. And like off to like the right of this interval. So that's what the first condition is saying. The second condition is saying is that it needs to be within some distance, you some distance delta of this point x naught. So like I'm not explaining this well enough, but like delta is like a radius. Oh, that's fair enough, color cone. Subset should be open. Uh, I'm not sure it needs to, Selenia, unless I'm wrong. I think for the reason I'm saying you can do this with a closed one. Oh, they do what color cone says. That makes so much more sense for why this is the theorem. Hey, Ayush. Yeah, I. It's been a minute since I've streamed math. I'll stream it more often for the next like few months. I was taking a bit of time off because of spring break. I am the theorem. Okay, so thank you for linking this, Luke, because this does clear up why this is a theorem, because they define continuity in a different way. And yeah, it looks like Max is saying that too. It's much harder to understand with a quantifier in X. Other places people use it. Um, we're saying it needs to be true for any X within a certain range of your point of interest and in the domain. So it's not just any X at, like you want. But like if this is your point of interest here, X naught, the task for the person like trying to prove this thing holds for a specific function means finding this delta such that for a given epsilon, this statement is true. And what delta does is it tells you how far away from your point of interest you're allowed to go. So if delta is like this distance here, it means that we need to be the wording of this is so like tricky that I keep like tripping over myself, but it's about bounding the actual like values of the function within a certain range of x values. And I might not be getting to the actual thing that you're asking. Like I might be misunderstanding what your confusion is. I don't know all the continuities that are out there, Dessen. I don't know enough analysis. Um, I I think they intended it to be translated as for all x in domain F. Oh yeah, that could be another way of thinking about it. Aeneas, or I think it'd be like that's also proper. If I misunderstood something about the wording, that makes this actually completely consistent. The question is, if I misunderstood something about the wording, it makes this actually completely consistent. You are the epsilon that made me continue my life. Oh no. Okay. If I misunderstood something about the wording. I think the wording of this is consistent. I can only think of like uniformly continuous and Lipschitz, or no, I don't know if Lipschitz continuity is a thing. I don't remember. Um, that like it's never easy to read like math speak, but I do think that what the book has written makes sense if you read it the right way. um, Really, like, the main thing to worry about is, I think, this, like, inequality here. If you're confused on this in domain of F, I think it's more just, like, dealing with some, like, edge cases that could potentially happen with subsets of R. And also just, like, being about, like, what X should be, I guess. But, like, we need both of these things to be true about X at the same time. So I hope that that answers your question, but if not, please let me know. Epsilon-delta stuff is always, like, really tricky. So, no worries. Oh, yeah. Um, I think I want to call it here then. If there's no further questions, I'm tired. um, yeah, let's call it. Did I get good at doing grad homework? Well, I'm on spring break still. I don't start up again until Monday. Yeah, I was definitely stressing there for a good, like, 2 months. I guess I've gotten better at doing grad homework in terms of just going to office hours multiple times a week, and they usually will get you really close to the answer. Oh, before I forget, I'm gonna cut the YouTube stream off here, and it's here on YouTube. Thanks for being here. On Twitch, we're gonna look for a raid. See you, YouTube. Oh, hey, Fenlux, this is the song. No, it's not.